Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to be looking at a limit. Now, this is something that you might see in a Calc 1 course. And when I was teaching calculus, the hardest thing for any calculus student was the algebra. And so what we're going to focus on today is mainly the algebra that's going on the inside of this limit here. So even if you don't know what a limit is, that's okay. You can still follow along with the algebra. As long as you know the algebra, when you get to a calculus class, you'll find the calculus is never that difficult. It's always the algebra that's the struggle. So we're going to start off by noticing that we have in our numerator 2 plus h quantity cubed. And that's just going to be a little bit of a pain if we try and expand that by hand. That's going to take a long time and is just not worth it. So we're going to learn a nice way to expand that without having to do a lot of work. It's going to take less energy. And this can be applied to a lot of different things. So I'm going to do the generalization of a plus b quantity cubed. What happens when we have that? Now, we're going to have our coefficients out front, of course, when we work with this. I'm going to leave that blank for now, and we'll talk about that in just a bit. And then we're going to have our a and our b. And we're going to start with our a to the third power and b to the 0 power. And then we have our second coefficient. We're going to drop our power a by 1 and pick our power b up by 1. Coefficient again. Again, A decreases by 1, B increases by 1. And then we get to our last one, A decreases by 1, B increases by 1. So you'll notice here what happens is any number to the 0 is 1. So our A to the 0 and our B to the 0 always end up being 1 here. And when we go through this, we're just taking cubed, squared, 1, 0, and our b exponent goes in the other direction. 0, 1, 2, 3. So it's nice and easy to work out. This is going to be the same way if you are taking your entire expression to the fourth power up here or the fifth. You just start with that number and you work your way down or up based on your two different elements that you're working with. So next up, we have to figure out what our coefficients are. And we're going to go to the Pascal's triangle to work with that. You can read up about that. I do have a short video on binomial coefficients if you want to learn a little bit more. We're not going to go into the complete binomial stuff right now. We're just going to kind of do the short and scrappy version. When we're working with Pascal's triangle, we start with 1, 1, and then what happens as we move down is our new picture is going to take the top two numbers, add them to create our new one, and we always have ones on the outside. This is second row is for the second power. First row is if you're dealing with elements to the first power. Third power is our third row. So our coefficients are 1, 3, 3, 1. That just gives us our coefficients. If we had a plus b to the fourth, we would have 1, and then 1 plus 3 gives us 4. 3 plus 3 gives us 6. 1 plus 3 gives us 4. And then we have 1. And you can see this kind of builds to a nice triangle as we're working with it. That's why it's called Pascal's triangle. So those are the way that we make this much easier to work with. Okay, so I'm actually going to rewrite our limit. We're working with the limit as h goes to 0 of 2 plus h quantity cubed minus 8 over h. Now, whenever we work with a limit, the first thing we want to do is try and plug it in. You'll notice if you plug in 0 for h right now, we'd get 2 plus 0 cubed minus 8 divided by 0, which is bad. So we are going to work with it and see if we can get a better solution. Um, So, and I'm a stickler for writing out my limits out front each time. Here's our a is 2, so we're going to have 2 cubed, and our coefficient is going to be 1 times h to the 0 plus our next coefficient is 3 times 2 squared h to the first power plus our next coefficient is 3 times 2 to the first power h squared plus 1 times 2 to the 0 h cubed. All right, now I know that looks messy, but it's much easier. You can see we were able to kind of get it down in one fell swoop instead of having to go through and do several iterations of distributing things. Let's clean it up. 1 times 2 cubed is 8. 8 h to the 0, any number to the 0 is just 1. Plus 2 squared is 4 times 3 is 12 times h to the first power. We'll just write plus h. 3 times 2 gives us 6, and then we have an h squared. 2 to the 0 is 1. 1 times 1 is 1 times h cubed minus 8 all over h. Now that looks a lot better. It's such a difference to have that now. We can cancel our 8's out. We can see that is going to disappear. And once we have that, our lives just improve that much because now notice we have an h in every element in our numerator, which means we can pull an h value out. So we can get limit as h goes to 0. Let's yank an h out. We have 12 plus 6h plus h squared. We can always double check and see what happens if we take that h and we distribute it back in. We'd get 12h plus 6h squared plus h cubed. Yep, we took it out in the right fashion. Now that that is out, we can actually cancel it. Right, we have an h on the numerator and the h on the denominator, so those disappear. We are left with 12 plus 6h plus h squared. And let's go back now that we don't have a 0 in the denominator. We're going to plug in 0 for h when we do that. Notice our 6 times h goes to 0 and our h squared goes to 0. So we are left with the number 12, which is our solution for this limit. Please keep in mind the algebra is the thing that trips most students up, not the calculus. If you practice your algebra, especially without a calculator, you're going to do just fine. Thanks for listening.